And she's been working on fabulous. She's been just to know that the recording is a problem. Fabulous. 5 days sustainable development over the past 17 years, system analysis and modeling, environmental sustainability, and obviously with a very strong focus on LCA projects in agriculture as well as plastics. So we are really, really honored to have you with us. Once again, welcome to our online participants. Your questions and your comments, you can note them in the chat. Mr. Tulazani is sitting there in the corner that you'll be able to see. He's going to be your host online. So we are, it's wonderful to have you in the room with us as well. So without any further ado, Valentina, thank you so much.
Thank you very much for the kind introduction, and thanks for having me in person after so many years of Zoom, Teams, meetings, speaking to just a screen. At least I can see people now. So I'm going to present the results of the pathways model, which is the modeling tool behind the Breaking the Plastic Way global study, which has been actually contextualized to the South African context. Okay, let's start.
It's not
Doing anything?
coming.
There we go. Okay. I think now I'm going to say quite obvious things. So we know that plastic pollution is a problem everywhere and much more so in South Africa. We have a plastic consumption growing rate at 3% per annum. We have backlog in waste collection services. We know that about 37% of our households don't have a weekly waste collection service. When waste is collected, is disposed to landfills, many of them are not compliant to legislation, which means that plastic leaks to the environment at different rates, and we know it, we see everywhere. South Africa has a rich policy landscape to facilitate the management of waste, including city cleaning and waste collection and the adoption of the waste hierarchy. We have existing measures in place, but today they have been not so effective, or I don't want to say ineffective because it's negative, in curbing the growing plastic pollution. And we see more and more the mismanaged waste increasing. So, what are the tools that we have in our toolbox to try to address the plastic problem? We have bans, we can have alternative materials, we can recycle, of course, we can save, dispose in engineered landfill, which provide good containment. We can do incineration, of course, in South Africa is not done, and we can implement cleanup programs. But what are the questions? How do these strategies perform on environmental, economics, and social indicators? How applicable are they to materials and different geographies? How do the strategies interact? At which cost? And how quickly? I think this we are all in agreement now. So the global study, that's the result from the global study. It showed that no silver bullet, no one size fits all. So the global study compared the business usual, which is of course the trend at the top, with the pinkish wedge, which is what remains. So it took a wedges approach with each wedge addressing one of the tools. So we can reduce plastic by eliminating, banning, by implementing, by using the reusable items, or implementing different delivery modes, like refilling scheme. I think people will talk about more on refilling. We can further reduce using material substitution as long as the functional requirements is preserved. Of course, we can recycle as much as we can, as much as possible to do, and we can safely dispose. Of course, the global study consider also incineration and conversion of chemicals to fuels. So what we did was to we contacted Kew and Oxford University to be the guinea pigs, because that's what we did, to test the application from global scale to country scale. So the research question we tried to answer was, can the pathways tool be successfully applied to the local scale and to a developing country context like South Africa? And based on the application of the pathways tool, what should South Africa's agency response be to addressing plastic pollution? So let's start to answer the first questions. So that was my headache for the last years or so. So first thing first, we have to adapt the system, well, the system map, which means the model to our context. We done just adding things that made sense to us. So we add, for example, this thermal treatment without energy recovery, which is something that happens in South Africa at small scale, where plastic waste is burned into existing operation, like a substitute or feedstock. We added, for example, this flow here because when we had workshop with experts, we realized that although plastic waste is collected, sometimes it doesn't make through at all any sort of sorting. So it just disposed off. We added this other flow, which accounts for the recovery of waste performed by informal sector from sanitary landfill. And we added other small flows here and there to account for beach cleanups or dump site cleanups and other stuff. So we went through several iterations to get to that. So that was the first thing. The other thing is that data. So the pathways tool is rather data intensive tool. So we contacted everyone to have data from various sources, government report, industry report, sector report, papers, studies from academics, whatever. When we had data gaps, because we weren't able to find, to sort all the data needed, we were quite lucky to rely on the default upper middle income archetype data. So they were thankfully to the global study. All data have uncertainty, which propagates to the model, which means that when you get the results, you also get the results and the confidence interval. So the model runs over a 25 years period. So we have historical data for 2016, 2020, and then all the projections were inferred based on industry and waste sector trends. Okay, we model just 3 scenarios, but the possibilities are kind of endless. Whatever what if you have in mind can be modeled through the tool. So as a baseline, we model the business as usual scenario, which means just keep going what we are doing without no further intervention. And let's see what will lead us. Then we wanted to understand what the extended producer responsibility regulation could do and over these 5 years. And then, as a last thing, we model an optimal system change scenario, which it's a kind of trade-off between economic and environmental consideration. Okay, results. So what the business as usual tell us? Well, as you can see, plastic will near double in the next 20 years. I think that comes with no surprise. And due to the waste mismanagement of plastic, we quite have number of leaking into the environment as overburning, land pollution through leakage, littering, and illegal open dumping, and aquatic pollution because, well, the aquatic environment is the ultimate sink. Okay, so that was the situation, and then we say, okay, let's see what the EPR can do. So we modeled quite a number of these sub EPR scenarios. Actually, we modeled more than this number 6, but the other were like variation on number 6, which I think didn't make any difference. So the first one is what I called, it's called a kind of baseline scenario, and based on improvement and collection and recycling rates only. It meets the collection rate, but it doesn't meet the EPR targets for recycling. And it has unintended consequences, that's what actually we observe, of increased post-collection mismanaged waste. So trying to focus it just on these consequences, we developed EPR 2, 3, and 4, which are just aimed at improving the managing the sorting of mixed plastic waste. None of them did the trick, but yes, EPR 5 did it. So when you improve collection patterns, separation at source, you have enough plastic waste, which is collected for recycling, so you can see a nice flow going through. And you started to avoiding these unintended consequences, and much more so if you couple these source of separation with improvement in the mixed waste sorting, what we call dirty MRF, because sadly I didn't allow it down. So I'm going to present now the results, mainly for business as usual, which is what we compare with, and EPR 1, 5, and 6. So the best we can do. Okay. This is total plastic pollution. Then we have a bit of detail on the trees, on the aquatic land, and open burning. So if we apply the EPR scheme, total plastic pollution can be reduced by 31% if we apply EPR 1, up to 33% if we apply EPR 6. This is mainly due because collection has improved, so the uncollected waste which is left behind is greatly reduced by almost by 50%. So how we implemented, so the collection rate and the recycling rate were increased up to 27 and then were kept constant. That's why you see this downward spike. That means when we pull the plug, done. 5 years of improving, done. What's happening? We start to, because we have the plastic consumption growing, it will start eroding all the gains, all the benefits that the EPR started doing, and you see you just going backwards. So EPRs now it's okay, provide a conservative approach, but we need something else beyond 2027. This is just a detail on aquatic pollution, land pollution, and urban burning. So what can be achieved in each of these ultimate sinks. So we can see between 19 and 25% reduction in aquatic pollution, between 31 and 33 in plastic pollution to land, and between 32 and 35 plastic pollution to air through overburning. As you can see, after the EPR came to an end, the 5 years, we start going back to the level we were in 2020. So it means that EPR create a kind of stabilization wedge for plastic leakage to the environment, but it's just partially effective, especially if we stop. I can't emphasize this. Not enough. Okay. What are the benefits? Anyway, so that will be for sure an increase in formal collection. So an additional 6,500 kilotons would be potentially collected. Between 4,000 and 12,500 kilotons of additional plastic waste will be potentially sorted through both the dirty MRF and clean MRF, so a combination between source of separation and mixed waste, and between 1,500 and 5,300 kilotons in recycled production. Recycling rates can go up to 35%. Of course, the more you do, the more they increase. What's happening? Okay, let's see other benefits. So on the greenhouse gas emission, each of the EPRs presents some benefits. So we can see the greenhouse gas emission does decrease 6.2, 12, 14, blah, blah, blah. So the biggest reduction are mainly in avoided virgin plastic production, which contributes to 10%, and avoided burning of plastic waste, which is left uncollected. Jobs. So is there potential for job creation? Yes. So we can go from 80% if we do the bare minimum up to 20% if we try to do our best. Mainly, of course, the job creation will be in all the formal part of the sorting, collection, sorting, and recycling stages. So 2.2 formal collection, between 1 and 13 formal sorting, 1 to 4 to recycling, which is mainly mechanical recycling. We also model a bit of chemical recycling, but it's a tiny portion. So the improvement of formal collection, sorting, and recycling will erode some jobs in virgin plastic production, but it's around 1% if you're considering overall. Of course, we have detail for everything within the same value chain stage, and those details will be in the report, which will be published kind of soon. So costs. The EPR scenario, they don't provide so much improvement in costs. There are small reduction here and there, and mainly because cost shifts between the different stages of the value chain. The greatest reduction in operational cost, in operational expenditure and capital expenditure is in the production of virgin plastic, where more recycled, of course, will replace the demand of polymers. And of course, there is quite a big potential revenue generation from recycled production, up to 125%. Okay, that's quite a complex one. Okay, additional infrastructure capacity and reward investments. So what does it mean with additional infrastructure capacity? So the tool consider additional capacity based on the maximum historical value reached. So it's something that updates year on year. So it compares what you have installed available this year with the original, with historical maximum, and is all enough. It tells you how much you need in each stage of the value chain. So the biggest chunk of additional infrastructure that we need will be is related with the sanitary landfills, although it shrinks a little. So it's the top bar, the gray one. It shrinks a little from the BAU to EPR6 because there will be less plastic waste disposed. The required investments, of course, also will decrease, or we need less capital expenditure to meet the EPR requirements rather than keep going what we are doing now. And it's mainly avoided capital expenditure in creating extra infrastructure for virgin plastic production, which is replaced by the recycled. In terms of investment, the best EPR, which is EPR number 6, if we combine formal collection plus sorting plus recycling, it will require 1,450 million US dollars. I know. Everything comes with a cost. Okay, so just recap on the EPR scenario. Overall, they have some benefits, so just don't blame them. So we just went through it, but it has to be implemented wisely. So just don't do the bare minimum, but try to make the best. So improve collection, sorting pattern, and at level also the dirty earth to achieve the EPR targets and to avoid unintended consequences, which is this post-collection mismanaged plastic waste. It's a conservative approach, so it needs further adjustments beyond 2027, because we see, I think it's quite clear that otherwise we're going just backwards. And if you recall this graph from the global study, it addressed just one of the wage, the recycling wage. So we need something else. EPR is okay, it's a good starting point. If the shock the system needs, let's give him the slap. But we need something else. This something else is what we call it's called the optimal system change scenario, which is we try to find a kind of sweet spot. Maybe it's not too harsh on like the EPR. So it's between least plastic leakage, lowest greenhouse gas emission at lowest cost possible with the highest job. So it's kind of finding the right trade-off that makes everyone happy or not so unhappy. What can we achieve? I think the slides speak for itself. So if we try to implement a combination of all these wedges, we can achieve 63% of total plastic pollution reduction. So as you can see, you don't pull the plug off, so you continue improving. It requires a combined strategies, a combination of strategy of reducing plastic demand, increasing plastic waste collection and recycling, and increasing safe disposal to sanitary landfill. Before you ask, we didn't model any incineration or other stuff. So it requires both upstream and downstream intervention. And so those are the numbers that actually provide the best answers. So plastic demand has to decrease by 2.5%, which collection and recycling has to increase by 4.8%, which kind of aligns with the EPR targets more or less. And disposal to sanitary landfill also has to increase, not just disposal, but disposal to sanitary landfill to improve containment, so to prevent leaking. What else we can do? So let's go a bit into detail. Aquatic pollution is reduced by 56%, land pollution is reduced by 66%, and air pollution from the burning by 63%, which is the double of the EPR. Greenhouse gas emission, 37%, is almost 3 times the EPR. Cost, 67% less. The EPR didn't provide much cost reduction. It's mainly as a result of avoided capital investment. Jobs, it shows maybe a slight increase, 3%, but mainly because it's balanced out the job losses in the which are associated with the virgin class production, with the job gains, which are more in the collection, sorting, and recycling. Okay, we're almost there. So what we need, a combined strategy is what we need to reduce plastic pollution, which encompasses plastic consumption, increased collection and recycling of all recyclable plastic materials, and properly disposed in sanitary landfill. Strategic intervention are required to reduce plastic demand, so we have to think about reducing the new delivery model, eliminate and substitute with alternative materials. Management intervention to improve waste collection and management by addressing service backlogs and in all municipalities. We have to improve the collection efficiency for all plastic with the introduction of separation at source And let me add also, we can't be shy to say we don't have the problem of dirty of the mixed waste, so this also has to be addressed. We have to improve the state of our landfills, even though the don't build new one, just try to make the one that we have compliant with legislation, so they offer the level of containment they should have. And it requires a collaborative approach between all the stakeholders. What lies ahead? So just for the study, so the technical report is being finalized. We're doing the DMCA just now. So the whole project has been funded between the Department of Science and Innovation, the Department of Science and Innovation, and also through CSIR funding, and will be made publicly available on the Waste LGI and Roadmap website as soon as it will be released. We hope that the study provides a sound evidence-based and from South Africa response to addressing plastic leakage into the environment. What we are keen to do is to engage with private, public and private sectors on the details of the report, to have small group workshop, one-to-one engagement, so to discuss all the implications and all specific actions to be taken. So the report also contains some system interventions already based on the results. The CSIR will launch the Solve Plastics Africa. It's a science, technology and innovation app, which aims at providing evidence-based solutions to address plastic pollution in Africa through various modeling capabilities. So we like to make available all the tools we have in our toolbox, not just the pathway tools. And we like to work with other African countries in applying the pathways model, so they don't have to go through this painful process we've been through. But we can learn and help each other in addressing plastic pollution intervention in country. And with that, I'm done. So I think I stayed enough space, enough time for questions. Okay, thank you.
Thank you, Valentina. I think there's a lot to chew on there. Any initial thoughts or comments? Lauren's hand was first. Sorry.
Thanks, Valentina. I think this was quite an intensive study, and I see there's a lot of collaboration with the pacts as well as Plastics SA and other partners. I just have a question about the systems, system solution slide. You spoke of the reduction, and then there's the demand to reuse and alternative delivery models. But then you speak about waste management, improving waste or management interventions. That second one. So it talks about waste management and separation source, but I'm sure that it includes product design. I mean, speaking to the targets of the SA Plastics Pact, if packaging specifically is designed to be recycled, for example, or reused, then the amount of waste would be significantly reduced. So I don't know if that was also taken into account, surely with the first one, with the reduction, but specifically with the management interventions, I mean, looking at product design so that it doesn't become waste, at all at the end of life, for example, looking at EPR, etc.
Okay.
You can use the click.
Sorry, just getting the mic to you so that our online participants can hear the reaction.
Okay, so in the optimal system change, we included the reuse, but we didn't include alternative material production as yet. So because there was a bit of uncertainty on that. So I'm not saying that this study ends here, for sure it has to come to an end at the moment. But for sure, all the what if can be added maybe at a later stage if we need extra answer for sure. Next.
So Celine,
You had a second.
William online would like to add.
Awesome.
Yes.
William online, do you want to add before we go to the next question? Go for it. You should be able to unmute yourself, William.
Hi there, can you hear me?
Yeah.
Yeah, great, thanks. So yes, actually that component, if you're asking about the reduce component, it actually consists of both reduction in terms of eliminating, in terms of switching to new delivery models, in terms of switching to new types of materials, for example, compostables, plastic compostables, but also paper and coated paper. So there's quite a detailed unpacking, in fact, of what that 2.57% reduce actually consists of. So it basically consists of reducing demand per se by reuse, new delivery models, and elimination, and then also switching to alternative materials in terms of switching to paper, coated paper, and compostables. So that's what compromises those two wedges, reduce and substitute. And together they comprise 2.57% per annum. So that's the kind of upstream solutions, if you like, thinking about making things more reusable, different delivery models, reducing the actual need for plastics in the first place, substituting to compostable materials. And then, of course, the other interventions are more downstream, you know, more recycling, improved management of the residual waste which is left in safe sanitary landfills. Thanks.
Hi there, it's Peter Skelton here from RAP. Just sort of building on that point, how did you determine what numbers to put to the alternative materials? Did you look at certain categories that you thought might be able to switch to alternative materials? Was it sort of just a figure applied to the whole total? And just thinking about those alternative materials still need to be managed. You know, they don't suddenly disappear. So I know it's a big topic, you've got to stop somewhere, but in terms of the very first slide, it had bio alternatives. Bio alternatives still need to be recycled, incinerated, composted, something. So, but the main thing is, what is there any details behind that substitute for alternative materials? Would be useful to know.
Sure. So in terms of the substitution, there is sort of global costs on what that would be, for example, and also the change in jobs. And of course, the kind of different amounts of waste and emissions will also change. So for example, when you use paper, you might require a heavier weight packaging item, and you might incur more greenhouse gas emissions downstream in the decomposing of paper in the landfill, for example. So yes, that is taken into account in terms of jobs and costs, and it's using global data. What wasn't in fact taken into account in the model is some of the costs of these new delivery models and elimination and actual reuse. So the actual costs of changing from a single use to a reuse, or switching to some kind of new delivery model which doesn't need that amount of plastic or packaging in the first place. Or the actual elimination, the costs and jobs of those weren't incorporated into the model. So it's very unclear what those would be, for example. So that I think requires some further work. And then the allocation you mentioned, or how one determined, you know, how much would be substitution and how much would be reduction. Generally of that 2.5%, it was quite an approximation. So it was using what would be termed perhaps, I think, global commitments from some of the large companies in terms of reducing that first wedge. And I think it's around 1.1% a year that there's a commitment there. And then obviously the model optimized to 2.57%. So the rest was allocated to substitution. Thanks.
Perfect. Thank you so much. I know we have some more online questions, but we had a question here. We had a hand from Doug.
Thank you, Valentino. Just a thought which I thought about is, if there's a plastic demand decrease, but the population growth rate and the demand for products and stuff is increasing, did you consider or bring into mind population growth rate in SA?
Yes, we did. So basically within the model, we've got a growing population and consumption and demand, and then it's taken into consideration.
Okay, got it.
Go,
So,
Valentina.
yes, so So yes, the model consider population growth, so the total plastic demand is actually modeled on the population growth. There was another hand in-house, is that hand still a hand? Are you good? Good, fantastic. So online, are we gonna unmute and ask?
In the Q&A chat.
Okay.
So Kelly McGurk online, hi Kelly, asked, I can't, are there any additional policy instruments assumed for the optimal system, e.g. higher landfill gate fees?
No,
No, no, I
Sure.
don't think so. I was also thinking William, so I don't think there are other policies that we considered. It's live online. We're gonna enable you to unmute. So if you want to raise your question.
Hi there. And just wanted to also find out, have we factored in using waste for biomass energy? Because I see this, we've got reduce, substitute, recycle, landfill. On this.
Biomass energy.
yeah, so there's a little of that in the model. I think Valentina can elaborate,
Well,
but
the only
I'm sorry, Tanya.
me and you choose. Okay, so the only waste to energy treatment we included is the thermal treatment without energy recovery. So which account for plastic waste, which is burned in existing operation, mainly cement, kiln or boilers. These are tiny portion. We are talking about 3,000, 4,000 tons per year. So it's happening. Maybe it will happen even more. The target then. Do you want to elaborate on that? New question? Anyone
so just,
else? Do you want to elaborate on the current point? New question?
no, I was just
Okay.
going to say that, you know, South Africa is not very keen on incineration, clean incineration with energy recovery, as perhaps happens in European countries. And we, you know, favor landfilling. So basically that option, incineration with energy recovery, we haven't yet put that in the model. It might be interesting to explore, but it's currently not really a policy option, it seems, in South Africa. Thanks.
Perfect. We have a question here, and then I'll move to the question at the back.
Sure, Junaid here from EDCO. So my question is on the informal sector jobs. It doesn't seem to grow much with EPR coming into play, which seems counterintuitive. So I just want to understand how you guys forecasted that.
Okay. Okay, so it will, okay, what we observe, what increase is this. Okay, so the informal collection sort is quite a multiple answers. So the informal collection sorting gathers waste from curbside collection. That's what comes from here. Dumpsite recovery, that's the big chunk, actually the biggest, and a little bit from sanitary landfill. At the moment, and I raised this concern with the developer, these unsanitary landfill dumpsites, these dumpsites recover it's a kind of flow you calculate outside the model, based on population, blah blah blah, various things, and then you put like an amount of waste which is recovered. Of course, it grows according to the population and the plastic consumption trends. I also, when I ran the model for EPR, I was expecting to see this, but because it's not yet linked, because it's a kind of absolute flow, it's not a percent, it's not expressed as percentage, it doesn't show what I want to see. So I was also bit, I raised the concern. It's not an easy one to fix because we fix a lot of things up here and there. Of course, we can see that here it's growing. So curbside collection, especially if we promote or we integrate or we foster, can have an impact. But this kind of remains
plastic, if you know what I mean. And it's something that has to be addressed properly, and I'm keen to address it properly.
I knew that this was coming.
Question at the back.
Thanks for that, Prezo. I'm not sure if this was part of your scope, but as a consumer, as a PRO, participant member, as corporate, when I saw the $1.4 trillion US, my question, my comment, my concern was around the funding mechanisms. You know, somebody must pay for it, and you know, do I want an extra $3 on my Valprep or flow of water? As a taxpayer, is it gonna be more money on my tax rates as corporate? Is that more, you know, money to pay? So did you guys know? Sorry, I shouldn't be very So just a funding mechanism, and I'm asking this as well because you don't want there to be a barrier that says, oh, this is probably too expensive, let's pack it. And the next generation will worry about it. So I think for me, the systems is beginning to paint a picture in my head that if you start doing these things, you're chipping away the problem, removing the needle. But you don't want that those number of zeros in US currency. You say, oh, okay, maybe let's try the cheaper alternatives. Which is not a problem. So question, funding mechanism, what's possible, and is it sustainable? Thank you.
That's a question for policymakers. So, of course, we can provide the evidence base. So, of course, the numbers are scary. I'm totally agree with you. Then the solution is where to find the extra money that we need. So I think there's a bit ongoing discussion where the EPR field has to go, where to go, why to go, how to be applied. So there's a question that is beyond the scope. So yeah, we can just look at it possibly constitute that.
And thanks, William. We'll also give you a gap to speak to that as well. And I think one, we need to understand how that figure was calculated. So I think that would be useful to look at the costing there. And I think that will also come out in the report. But what will also be mentioned in the report is the cost of not doing anything. And it does look at the cost at a system level. And the way we currently work in our system is that we look for the costing at our segment only. But we do need to consider the system cost. So that's something to emphasize. And I know what came out in the global plastic model is the cost of business as usual is much higher in order to be able to address plastic pollution and to manage what will happen as business as usual. So what that figure doesn't show you is the cost of not doing anything. And it actually, and I know there's a lot of assumptions within that, and the CSR will be really good at giving you their assumptions and the basis on which they make their calculations. But I think that's something to keep in mind that we're not presenting here. But how we solve that, because where you sit, Nicelo, you can see your section, you know, of the value chain. But we need to be able to translate that effectively. And that is something of what EPR is doing, is some of those external costs which producers haven't been liable for, haven't been costing for. So the cost of collection, sorting, and then recycling of your products hasn't been included previously. So that's partly, and as we know, EPR is the baseline, is what EPR is moving towards. But we do need to consider that system as a whole.
The externalities that never been considered at the environmental costs.
We have 2 minutes left of the session, but I think this is important to try.
Thanks, Valentino. If you can just go to slide 11. EPR. The next one. Just a question, the line is going down and then it increased. My understanding is that you only worked on a 5-year EPR targets and haven't extended that beyond that. So should that be increased or changed? It will obviously change the model. If you just can confirm.
Yeah, indeed. So we implemented the 5-year targets Sorry.
We implemented the 5-year target increase after EPR regulations. And then we actually stopped. Okay, where we are after 5 years, here, just keep constant. And then what's the effect? Okay, we did the shock, well, the system get shocked. But then because of the trends of plastic consumption, it will slowly erode all the benefits of the 5 years. That's why I'm saying we need something else beyond 5 years. Yes.
Okay, sorry, so just to confirm that you keep the collection and recycling rates applied,
Yes.
but because of the the growth in population and the growth in consumption that then erodes.
So
Okay.
you start here, increase, you're up there, and you get constant. But then because this keeps growing, it will slowly get the benefits of the 5 years effort.
Okay, and we do understand, and I think this is embedded in most EPR systems, that we do aim at continuous improvements and updating of the targets as we hit certain milestones.
Yeah.
We have reached the limit of our time, but thank you, Valentino. I think there's quite a bit more to discuss, and that's why we have 15 minutes that we can have some further discussions over snacks and coffee. But thank you so much. This is fascinating, and the timing is absolutely perfect. So thank you for sharing. So we have now really established that EPR is a very important intervention, but it's one of the interventions, but it still is an important intervention. So after discussions over snacks, we will come back, and Ruan and Kirsten will take us into a deep dive session around just some of the practicality. So enjoy your snacks and your coffee. I hope because you need it. Yes. And then we'll come back and we'll explain how the session will work after lunch. Thank you for our online people. Thank you for joining us. Lovely to have you with us. Little bit of a glimpse of what's happening at the SA Plastics Pact Member Conference. Thank you very much. Sorry, Clive. Would you mind just noting your question and William? Oh, fabulous. Okay, so those are legacy hands. Fantastic. Thank you for joining us, everyone. Goodbye.